Right, so we're going to start this week with chapter 4, which is about discrete probability distributions. So the first section, 4.1, is just called probability distribution. So we're going to define what a probability distribution is. And so we start with random variables. So this is the first time that we are introducing the concept of a random variable. So a random variable represents a numerical value associated with each outcome of a probability distribution, and it's denoted by X. So basically, it's every possible value that X can take. So for example, X is the number of calls a salesperson makes in one day, or X could be the hours spent on sales calls in one day. And we have two types of random variables, discrete and continuous. A discrete random variable has a finite or countable number of possible outcomes that can be listed. So for example, the number of sales calls a person can make in one day is countable, right? They can't make an infinite number either, but it's something that we can count. They could make 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there's some maximum that they can probably make. So the random variable X then represents the number of sales calls a person makes in one day. And this is a discrete random variable because it's countable. And the possible values that X can take are 0, 1, 2, 3, 4, 5, and so on. And then a continuous random variable has an uncountable number of possible outcomes, and it's represented by an interval on a number line. So the hours spent on sales calls in one day, because this could be fractional, so the hours spent can be anywhere from 0 to 24, obviously, unless they're running some type of sales call marathon. Usually it would go from 0 to 8 because most people work 8 hours a day or maybe 10. And they could spend any amount of time falling anywhere in between, right? So things that are generally continuous random variables are things like time. Time is always continuous. And even when it says number of hours, hours can be, again, fractional amounts. So time is always continuous. Volumes of things are continuous. So like the volume of water in a pitcher at a given point in time, right? That would be a continuous random variable. Height and weight are also continuous random variables. So only countable things are discrete. Right, so we're going to start looking in this section first. We're going to be looking at discrete probability distributions. So a discrete probability distribution lists each possible value the random variable can assume along with its probability. So it's basically a table. And so the first column is the X values, the values that the random variable can take. So if we go back to the sales call, this example, the values that X can take as they're showing it is 0, 1, 2, 3, 4, 5. So the probability distribution would be a table where the first column would be the values of all these X values, 0, 1, 2, 3, 4, 5. And the second column would be the probability of each of these. So the probability that X is 0 and the probability that X is 1 would be next to this one, and so on. Okay, the probability of each value of the discrete random variable has to be between 0 and 1. It's inclusive. So if the probability of X is 0, that means that can never happen. So X never occurs. So for example, if we put in -1 for the number of sales calls, the probability that X is -1 is 0. If it's not possible for the person to make 0 sales call, then the probability of even 0 would be 0. So Anyway, the probability has to be between 0 and 1 inclusive, and it equals 1 if it's always the case. So if they always make 5 sales calls every day, okay, then the probability that X is 5 is 1. And when that happens, then this would be the only possible value for X. The sum of all the probabilities has to be 1. This is really important, that otherwise something is missing. So you didn't actually include all the possible values of X. If you sum them all up and they don't equal 1, you might have only looked at 1, 2, 3, 4, and 5 in the sale call example and forgot to include the probability that they didn't make any. So the way that we construct it is we let X be a discrete random variable, and the possible outcomes are X sub 1, X2, up to Xn. So there are n values that X can take, and we call that the first possible outcome X1. So in the sales call example, X1 is 0, X2 is 1, X3, let me go back here, it's probably easier to see it. This would be X1, X2, X3, oops, sorry, I'm on the wrong one. This would be 0 is X1, this one is X2, X3, X4, X5, X6. Okay, and there are 6 here. Our n is 6 because there are 6 possible values that the discrete random variable X can take. And then we would make a frequency distribution. This is where I was saying it looks a lot like when we did our frequency distributions. We would make a frequency distribution for the possible outcomes, and then we would sum the frequencies, and we would find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. So we're finding the relative frequency here. So we did this back in chapter 2. This is the relative frequency, right? And then you'll check that the probability is between 0 and 1 and that all the values sum to 1, which is exactly how it worked when we did this with relative frequencies. So if you're just given a probability distribution, remember the distribution has all the values. So when you have a probability distribution, you have everything, all the probabilities will sum to 1. Then we can calculate the mean by taking each X value, multiplying by its probability, and just summing up those values. So we could take our table of, we have our X values in the first column, 0, 1, 2, 3, 4, 5, 6. And then we have our probabilities of each X next to it. Then we create another column where we multiply X times the probability of X. And then we sum up the values from that column, and that gives us the mean. Right? And then to calculate the variance, we take, once we've calculated the mean, we create a new column that is X minus the mean. And then we square that, and then we multiply that, each of those values in the table, by the probability of X, and we sum those up. So this is from a new column. This is, the first one would be X1 minus the mean. So that would be 0 minus the mean squared times the probability of 0. The second one would be 1 minus the mean squared times the probability of 1, and so on. And then we would sum all of those. And then the standard deviation is just the square root of the variance. So that's how we calculate that. And I will show you at the end of this section how to do this in Excel. And then a new thing introduced in this section as well is the concept of an expected value. So the expected value of a discrete random variable. This is what value would we expect to get if we picked a salesperson at random and wanted to know how many calls they make in a day. Our best guess, our most unbiased estimate of X is the mean. So the expected value of X is the mean. And there's new notation here. So we denote that by E of X. So just like PX means the probability of X. So Px, this is the probability that x equals, for example, P0 is the probability x equals 0. So this is the expected value of the random variable x, and it is the mean. And this is just the formula from the mean, the sum of x times Px. So that is the end of this first section. So before I open up the homework for that, let me go back in here where we did our relative frequency distribution. So I just want to look at this one. Okay. Oh, this doesn't work because these are classes. All right. So we'll have to do it from this chapter. Sorry about that. Okay, so let's open up the homework from this chapter. So that doesn't work because those relative frequencies that we had from that chapter, we used classes. So we didn't calculate the probability that x equals 0. What we've calculated is the probability that x is in a particular range of values. So using this formula won't work in that case. All right, so let's look at the homework. Unit 3, assignment 1. Okay, I'm going to open this. I'm going to open up my Excel spreadsheet next to it. Oh. All right, and I want to add a new spreadsheet. Make this bigger so you guys can see it. Okay, let's skip that one. Okay, so here is the first one. Oh, so we can do problems 1 through 5 from this. So let me find which one we want to do, because some of these might be the same. Okay, so I'm going to start with this one. Number, this is, sorry, number 4. So I'm going to start with Unit 3, assignment. Number 4. Right, so it says use the probability distribution to complete parts A and B below. So first, always copy to a clipboard. Otherwise, it opens a new Excel spreadsheet. So I'm going to copy this to a clipboard. And I'm going to paste it over here. And I realized I don't think I named this. What spreadsheet am I on? Here, I'm in sheet 2. So let's call this chapter 4. And then also I can move this to the end. It should be after chapter 3. There we go. All right. So use the probability distribution to complete part A and B below. The number of defects per 1,000 machine parts inspected. So the number of defects that we can have is 0, 1, 2, 3, 4, or 5. And then here are the associated probabilities. So this is the probability I have 0 defects, 1 defect, 2 defects, 3 defects, 4 defects, and 5 defects. And so it wants to know what the mean is. So remember, first of all, let's verify that this is a probability distribution. So to verify it's a probability distribution, because we can't do anything if it's not a probability distribution. So I'm going to go down here and I am going to do, I think it's under formulas. It'll do the sum for me. Auto sum, and it automatically puts in the formula equals sum, and then notice it's highlighted the data. So I can type in this formula equals sum and then just highlight my data, or I can just use this and it does it for me. Okay, let's make sure that's 1. So we verified that. So this is a probability distribution. And now the mean of X, I'm going to pull this from the, so to get the mean of X, I was going to pull that back out of the homework. Sorry, the presentation. So remember, the mean of X, mu equals the sum of X times its probability. Let's see if I can copy and paste that into here. Okay, so the mean of X is, or the mean, sorry, is the sum of X times its probability. So I want to create a new column here. So this is X, right? And this probability, I'm just going to rewrite this as the probability of X. So this is X, this is the probability of X, and then I need a new column that is X times the probability of X. So I'm going to go equals X times probability of X. Right? And then I'm just going to, so again, this is X blue times red, X times the probability of X. So it's the right formula. And I'm just going to copy this like this. Okay. So 0 times PX is 0, 1 times P1 is 0.287, and so on. And then again, we can use the auto sum here to get the sum of X times PX. Whoops. And it's 1.484. So back into our homework assignment. It wants it rounded to 2 decimal places. So I always like to let Excel do my rounding for me. If you go home, there's, and the rounding option is here. Okay, so the mean is 1.48. Oh, 1 decimal place. I don't know why I thought it said 2. Do that a lot. 1.5. Okay, and then the variance. So remember the formula for the variance is this one. So we need to take each X and subtract off the mean and then square it. Let me see if I can copy this formula over as well. This is so big. Just want to make this more normal. There we go. So the variance should be sigma squared is X minus mu, the sum of X minus mu squared times the probability of X. Right, so what I need to do, I have my mean. And then I need to create a column that is X minus mu. Okay, and then I'm going to go ahead, I'm going to do this in 2 steps, but you can do it in 1 if you want. And then I'm going to create another one that's X minus mu squared. Okay, and then I need, I'm going to copy this, just makes my life easier. X minus mu squared times the probability of X. Okay, so I'm going to create 3 columns to do this, but you could do it in just 2 steps. So this is equals X minus, here's our mu, okay, X minus mu. So now I need to anchor the mean. So now I can copy this formula. So 0 minus 1.5 is minus 1.5. 1 minus 1.5 is negative 0.5, and so on. So one of the reasons I like to do this in 2 steps is I can see really easily that I did this correct. And now this one, I'm going to go equal this value squared. And now I can square them. And what should happen, the one that's smaller here, these smaller numbers, when I square these values, and notice these 2 didn't come out exactly the same. I'm just checking to make sure it's squaring them. Oops. So these 2, even though they say negative 0.5 and 0.5, which should give me the same answer, remember, this is not 1.5, it's 1.48 something. So that's why these 2 are not quite the same. But you should also see that when we get closer, the values closer to the mean, which are 1 and 2, that this squared value gets smaller and then it grows again. So that's what we should see happening. So that's part of why I like to do it that way. Okay, and then I'm going to take the value I just calculated, X minus mu squared, and multiply that times the probability of X, this value here. Okay, and if you double click, you can make sure it's doing the right thing. X minus mu squared times PX. Okay, so now I'm just going to copy this formula down. And I should be able to click anywhere in the table and make sure it's doing what I want. This one should be doing, make this a little bigger. This one should be X minus the mean, which it is. This one should be that value squared, which it is. And this one should be the squared value times the probability, which it is. Okay, and then to get the variance, we're going to sum these. So this, again, this is the mean here, right? And to get the variance, I'm just going to sum this. So if I go to formulas, auto sum, and this is my variance. Okay, and then to get the standard deviation, which I don't think they ask us for, but if I wanted the standard deviation, I'm just going to do it here. Oops. Standard deviation is the square root of the variance. So I'm just going to go equals SQRT and put in the variance. And now I have my variance, my mean, my variance, and my standard deviation in case they would ask for it later. All right, so my variance, and they wanted it to 1 decimal place as well. If I go home, I can make this 1 decimal place, and so the variance is 1.6. Right? Oh, it did ask for the standard deviation, and the standard deviation to 1 decimal place is 1.2. All right, now interpret the results. The mean is 1.5. So the average batch of 1,000 machine parts has 1 or 2 defects, right? It's between 1 and 2, 1.5. So usually we would see 1 or 2 defects. The standard deviation is 1.2. So the typical number of defects in a batch of 1,000 is, so remember that 68% of the values are within 1 standard deviation of the mean. 95% of the values are within 2 standard deviations of the mean. But the typical, what they call a typical number of defects, is going to be within 1 standard deviation of the mean. So if the mean is 1.5 and the standard deviation is 1.2, 1 standard deviation below the mean would be 0.3, and 1 standard deviation above the mean would be 2.7. Oh, it's not asking us that. Deviates from the mean by about 1 defect. Sorry. So deviates from the mean by about 1 defect. I thought they were going to ask me for the range. All right. And then in a game of roulette, a player can place a $6 bet on the number 19 and have a 1 in 38 probability of winning. If the metal ball lands on 19, the player gets to keep the $6 paid to play the game, and the player is awarded an additional $210. Otherwise, the player is awarded nothing, and the casino takes the player's $6. Find the expected value of X for the player for 1 play of the game. If X is a gain to the chance, then the value will be negative if we're expecting a loss. Okay, so if we're expecting to win, it'll be positive. If we're expecting to lose, it'll be negative. So what we're going to do for this one is we are going to create a probability table. Okay, so I'm just going to copy this part here. And I'm going to do this is number 5. So let me put down, what are my possible values of X? We don't need all of these. Actually, I should have copied that. All right, so I'm just going to call this X. We just need X times the probability and the probability of X. So let's see what can happen. So a player can place a $6 bet. I'm going to copy this into my Excel spreadsheet. Maybe not. Let me see if I can just copy it from here. So I'm trying to open up, here we go. I was trying to open up my snipping tool. Shoot. All right. This is what my problem says. Okay, so in the game of roulette, the player can place a $6 bet on the number 19. Here, let's move this down. Here, so we can see it. There we go. All right, so the possible values that X can take, if we land on a 19, we get to keep the $6 and we get an additional 210. So in this first case, we get to keep our $6 and then we get awarded an additional $210, means we make $210 positive. Otherwise, we're awarded nothing and the casino takes our $6. So our possibilities from the perspective of the player are we either make $210 or we lose $6. We don't make 216 because the $6 we just get to keep it in the first example. All right. So these are the two possibilities, and the probability of winning is 1/38. So I'm just going to go equals 1 divided by 38. If you don't put the equal sign, Excel will think that you're putting in a date. Okay, so this is the probability that I win and the probability that I lose. So remember that the complement of an event, so the probability of the complement equals 1 minus the probability of the event. Remember, an event's complement, they denoted that in this textbook with E prime. So the probability of E prime is 1 minus the probability of E. So the probability losing is the complement of winning. So this one is 1 minus the probability that we win. Or we have a 37/38 probability of losing. That's the other way you could do it. You can put this in as 37/38. So these are the two options. I either win and I get $210 with a probability of 0.026, or I lose and I lose $6 with a probability of 0.974. Okay. And then they want us to find the average amount. I think that's what they were looking for. The average amount that we win or lose, right? The expected value is what? So the expected value is the mean. So I am going to go up here and I'm going to copy these formulas. Oh, no, I don't need this. Never mind. That's for the variance. So I just need an X times the probability of X. I go equal X times the probability of X. I'm just going to copy that. And then remember the mean is the sum of this so the mean is negative 0.32. They want us to round this to the nearest cent, and the nearest cent is 2 decimal places. So it's expected that we lose 32 cents every time that we play, which is how the casino ends up making money. All right, and that is the end of section 4.1. So now you are able to do numbers 1 through 5.